Ladies and gentlemen, welcome to
Sucrose.
Sucrose. Allow me to demonstrate the Lewis dot structure of sucrose. It's a very complex molecule, two halves, so I'll be doing the first half and then the second half will come later. Hopefully I'll be doing it quick enough. I need a better black. We have carbon, oxygen, we'll have a bent. Perfect. Now my companion Ryan will explain to you more in depth about each of these.
Hang right, I will. Okay, so there are two shapes in this entire molecule, or this entire sucrose diagram. So there are bent molecules and tetrahedral molecules. So, where these are found, all of the bent molecules are found on any of the oxygens with the two lone pairs. So for example, we have this oxygen right here that are just connected to the hydrogen and carbon, or this oxygen right here. Those are both bent molecules. So they have a, because they have two lone pairs on the center atom, they will have a angle degree of less than 109.5 degrees Fahrenheit. Now, the tetrahedral molecules are going to be any of these carbons that branch off to four different atoms, right? So, for example, this carbon right here is going to have a tetrahedron shape because it's connected to 1, 2, 3, 4 other atoms. That can be found in a lot of places. For example, this carbon right here is connected.
Yeah, there you go.
And that.
There we go.
Yeah, that's connected to 4 different ones.
What?
Now those are going to have an angle measure of 109.5 degrees Celsius. So, yeah, all of this is going to be polar. None of this is symmetrical. So basically that means
They like polar bears.
yeah, polar bears like sugar. You know, the slushies.
Icy.
Yes. So polarity means one. There's going to be a positive charge from one atom attracted with a negative charge from another atom, and as you know, opposites attract. It's biology. That's
Then why doesn't my love love me?
not enough sugar.
I'm single for all those ladies watching. Okay.
I'm Ryan.
Okay.
Okay. Another thing is
Hybridization.
no. Another thing is
Okay.
dipole. Dipole moments. So basically, those only happen in polar molecules, which just means basically that the positive charge attracts with the negative charge. And then also, as all molecules have, is dispersion, which is just the electrons kind of randomly connecting with each other. Also, as we have here, we have a hydrogen atom connected with an oxygen atom, which means H bonding, right? So H bonding is when a hydrogen atom connects with an F or an O or an N, a FON, which just means fluorine, oxygen, or nitrogen.
Sounds like a lot of fun.
Stop. So we have an H connecting with an O, so yeah, H bonding has all of them.
Perfect. Now, if you can direct the camera towards me, I'll be explaining the effects of sugar. Now, while sugar is a very controversial topic, I do assume that it's like kitty crack almost. Because as you drink sugar or ingest it into your body, it combines with other molecules in your system, causing you to be more hyper. And when you come down on that crash, you get more tired and you sleep and you just kind of pass out. But that's okay. This model that I'm showing you right here is more a textbook model. You might see this on Google if you search up sucrose molecule. But the premise is still the same. Lines are connected to hydrogens and oxygens and CO, show whatever. But anyway, so This is connected to a H note, and this is a CH2OH connected to another hydrogen. Very well, so this sugar, and while it may taste delicious, it does wonders to your body by increasing the heart rate and exactly your erratic movements. As you can see, kids bouncing off the walls. What else should I talk about, Ryan? About sucrose, it's wonderful.
How about those sigma or pi bondings?
Of course, because this thing has only one single pairs, or single bonds, I should say. None of these are double bonds or triple bonds or whatever, because this is pretty basic sucrose matter. That for all these will be one bond. Let's count them, shall we? We have, well, I shall abbreviate. No, we'll do it over here. How about that? Excusez-moi. Bring the camera over to me. Come down. Come. Let's count all the sigma bonds. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. I counted roughly 47 pi bonds. Maybe it's 40, 46. That's not a pi. No. There we go. Tis 46. 46 pi bonds this thing has because they're all single bonds. Therefore, we have 46 sigma bonds. None of these are pi bonds because they are no double bonds or triple bonds. These are all pretty basic.
Sigma bonds are always counted as 1.
Of course.
Right.
And we're back. Short intermission. Earthquake. Godzilla's out there wanting the sugar.
Back for us. We just cut the video.
Anyway, ionic and covalent bonds. What is the difference, and exactly how do we identify which is which? Right? Thoughts?
Okay. Basically, covalent bonds are anything that have both.
Hey Google, definition of covalent and ionic bonds.
Right. Ionic bonds, however, have metals in them, metalloids, right? So when a metal and a nonmetal are bonded, that is an ionic bond, whereas if there are only nonmetals, it is covalent.
Ryan is exactly right, as my sources have told me.
Dang right I am.
Because carbon is not a metal, it is technically a covalent bond, and hydrogen, oxygen, and carbon are also not ionic bonds because there is no metal.
Yes, sir. I don't see any metal here.
No metal in sugar.
Therefore, it's all
Make it in green. Make it look pretty. Gosh.
Covalent bonds.
Yeah. Perfect.
Covalent bond.
Covalent bonds, everybody. Now, how does this relate with other molecules? Well, as you can see, this section right here almost represents a benzene ring, but it's not because of this oxygen right here. If it was a benzene ring, it would be connected to other carbons, requiring it to be similar, but not really, because the carbon right here is connected to this hydrogen. It is satisfied with 4 pairs and 4 connections right here. But if we got rid of this hydrogen, it would need to connect to something else, so it would probably connect to this.
Yes, sir.
Of course. That is the difference and similarities of what this might represent. But it's not. It's really something unique, very something special. I love sugar. Sugar's like good.